All right, so to move forward, and we're going to do some applications just for Allie, because she's always asking me, Mr. Blythe, when am I ever going to need this? So this is why we're going to do it just for you, Allie. No, I'm just kidding. We do it anyways, but we need this change of base formula. Because our calculator can only do log base 10, we need a way to turn everything into log base 10. So write this formula down on your paper. And when it says log of x, this is always going to be 10 for us. So in your calculator, it's just log. So an example of this is if we had, let's say, log base 3 of 7. And we wanted to get non-exact, right? But we need some decimal approximation. We can change that to log of 7 divided by log of 3. And you can put this in your calculator. So get your calculator, and when you type this into your calculator, you have to do log. It should read like this, log, and then it'll automatically put that parentheses, and you do 7, and you have to close that parentheses. And then log of 3. And it should get you 1.32. And that's just a decimal approximation. It's not an exact number. So here's how we're going to apply that. We have 500 milligrams of medicine enters a hospital patient's bloodstream at noon and decays at a rate of 15% per hour. So we're first going to write an equation for the situation. So for an exponential equation, we have a times b to the x power. A is our starting value, so that's easy. And I'm going to write this up here because eventually I'll scroll down. So our starting value is 500. And then how we calculate the multiplier is we have 100 and it decays, it goes down by 15. So that gets us 85, and we move the decimal 2 spots to the left, 0.85. So that becomes times 0.85 to the t, where t is time. So the question's going to ask, and this is something nurses and doctors and anesthesiologists, anyone in the hospital system is going to use this type of exponential function all the time to know when you need to re-up someone with medication. So it says algebraically calculate how long it takes for only 25 milligrams of the original amount to remain active. So we're going to get a numerical number, how long to only 25 is left. And depending on the medication, that number, how much is left, really depends. So like some medication, 25, you'll still be okay, but some you never want it to drop below 250 milligrams. So that number really depends on what medication and the person and the person's size. So that number is really arbitrary and it varies a lot in different situations. So we're going to say, when is there 25 milligrams left? So we're going to solve this equation. So the first thing we're going to do is we're going to divide both sides by 500. And I need a calculator for that. So we get 0.05 equals 0.85 to the t. So now we're going to use our logarithm properties. We're going to take the log base 0.85 of both sides. And these are going to get rid of each other. So we have this exact answer. Not to the t, equals t. That answer is exact. But if you told a doctor, right, well, it's going to take log 0.85 of 0.05 hours, they don't know what that means. So we're going to use our change of log or change of base formula we just did. So this becomes log base 10 of 0.05 divided by log base 10 of 0.85. So you're going to type that into your calculator. Make sure you use that parentheses as well. And we get an answer of 18.43. It's that many hours. All right, so we're going to solve another one of these word problems, and then you're going to have the rest of this for homework. So we'll start this one together. So Felix puts $2,500 into a savings account that earns 8% interest each year. So we have y equals 2,500 times, I'm not going to do parentheses, just for me, I'm going to do that. And if it earns, we do 100 plus 8. To get 108, move the decimal twice. So times 1.08 to the t power. So for B, how much does he have after 8 years? Well, you don't need to do any crazy calculations. You just need to replace t with 8. And so when you do this, we have to remember exponents comes first. So if we're going to show our work, we're going to do 1.08 to the 8th power first. And that gets us 1.851. And then we multiply that by 2,500, which gets us $4,627. If you want to add the 32 cents, do it. I don't really care. But that's just like a quarter and a couple pennies. So the last question is the one we're here for. It's the big one. How long until he has 15,000 in his account? So to do that, we're going to replace y with 15,000. Next step here, think about it, 10 seconds. Divide both sides by 2,500. So we get 6, 1.08 to the t. And we're going to take the log base 1.08 of both sides. These are going to get rid of each other. So we have the log base 1.08 of 6 equals t. So that is our exact answer. And our approximation is going to be log of 6 divided by log 1.08, which gets us 23.3 years. So in about 23 years, that 2,500 will be $15,000. So I want you to try to finish this the best you can on your own. That's your homework. And submit that when you're done. Make sure you're showing all your work, each step,